Okay, welcome everybody. This is going to be my technical presentation of how to do U-axis turning on a mill in GibbsCAM 14. Now, this is some new functionality to 14, so you will actually have to have 14 in order to run this. But I think that it's pretty cool, and it's a good way of guaranteeing concentricity on a mill. So if you have some kind of roundish part like this, you don't have to do the entire part, obviously, so we're actually just going to be turning this top part here and the ID and adding some threads and stuff in there, but it's a good way of maybe freeing up a lathe or guaranteeing concentricity are the two main benefits that I've seen. So without further ado, I'm going to begin here by jumping into a machine simulation, and I have a nice DMU 50, I believe, and I've cut these. I've cut the stock in half so that we can see the ID and OD at the same time. But before I begin, I just kind of want to point out this U-axis tooling here. So this is all modeled. The cylinder part here was modeled by me per specifications, and then the U-axis head down here was actually got from the manufacturer's website, and then we just put in some standard insert holders into this contraption here, and that's how you set that all up. I'll be going over that in more detail here in a minute, but I just want to start off by playing it somewhat slow so you can see how this operates. Now, it's hard to tell from this toolpath, but the U-axis can actually dynamically decrease the radius that it's milling at. So we actually have a chamfer here, and it slowly increased the U-axis so that we could get a nice little chamfer here. And we'll also be doing the same concept here on the bottom to get an undercut. So I'm going to speed this up. Now, one thing to notice is that it looks kind of weird. I feel like you would be getting a lot of wobbling in real life with this, and there's actually not modeled here a counterweight so that you can actually go at really high RPMs, and so don't worry if it looks weird here. It's all perfectly normal. So I kind of talked through it, but we did do a little bit of the undercut here. All right, and now we're doing kind of the front face here, the top face. Speed this up just a little bit here. Oh, I tried not to miss it, but we did do the backside chamfer here with a groove tool. Now we're doing some ID work. Now notice that the tooling has changed here, right? So it actually did go and do a tool change, and it gets rid of that big U-axis head and adds another U-axis head in here. So the tool changing takes care of all of that. There is some behind the scenes work we have to do to make sure that it's in the right position when it changes and all that, and I'll go over that here in a second. You get an ID rough and an ID finish here. All right, and some threads. Cleaning up the threads here. So there's really a lot of functionality to this, a lot of power. You can see that we have threading, contour, and roughing operations, and we're doing all this on a mill. So that's U-axis turning in a nutshell. Now let's actually go over what I think is the difficult part of U-axis turning, which is the tooling here. once you actually get the tooling set up and you have your own library and you can save your tool list and all that stuff, it's pretty easy to use U-axis turning. A lot of the initial work comes in actually setting up this tooling. You can see that there's a lot to this mechanism here. And so we have the piece that goes into your spindle here, the cylindrical piece that was actually modeled by me. And then we have the U-axis head here. And then just whatever tool holder I select here will just be placed into here. And then obviously you're just going to set up your tool like normal, right? So I just have a standard 80-degree insert with my drop-down menu here selected. So that's nothing there has changed. We do have a way to say, okay, OD versus ID with the same tool, and it's actually how you would put the tool holder in there. We're doing OD with this tool, so this is the orientation that we want here. So that's all pretty standard stuff. Let's actually look at the intermediate tooling here. So if you missed it, I click this button here and that opens up the intermediate tooling where we kind of have this big old assembly in here, and this is actually new. This interface is new to GibbsCAM 14 as well, and some of this functionality is actually what allows us to do U-axis turning now. Before, it wasn't quite a question of capability of the software. It's just that we didn't have a way to set this up nicely and easily, and now that we do, we're going to be taking full advantage of this. So we have a tree here down, and this is where we find our tooling, our setups here. So in the machine definition document, the MDD, if you're familiar, this is what controls all of your machines and that kind of thing. So if I go into document control, just to explain what this is, I have a DMU50 here. That's actually listing the DMU50's MDD. So that's what I'm talking about. It's all how your machine is configured. And going back into here, on my MDD, which is typically set up by GibbsCAM, not done by users, but we have this tree where these axes are referenced. So C-axis in this case is our spindle, and when it spins, it's a rotational axis. You can tell by this kind of loopy arrow here on the axis, right? And here we have all our settings for this axis. Now, typically I would say you don't really want to mess with this. It's all pretty standard stuff. Interpolated means that as this axis rotates, it'll calculate how the other axes are changing. So I can't really think of a reason why you'd want to do parked. You just always kind of want to keep these axes uninterpolated, especially for intermediate tooling. Okay, and you can also exclude interpolation in a certain axis. Maybe I have, a rotary table or something on this mill. I might want to uncheck my other C-axis so it doesn't get them confused. But you also have some standing settings here with approach and retracts, right? So you can tell it, hey, where do I want to go when it approaches versus retracts, and we have a drop-down menu here with absolute, so I could have it always retract to 0. And that move is actually done after your retracts and stuff in your operation. So it's adding another layer here. But absolute, incremental, short rotation, or no move. Now, since this is a rotary axis, these are degrees, so I'm saying always return to 0 degrees. And then also, before unload and after load, we can return to 0 degrees. And I just typically always have these checked on. I can't really think of a reason why you wouldn't want to return to a position, because you can always index out of that, right? So that's how you set up the U-axis. Now this C and this U will actually be controlled by the MDD, so you don't really have to worry about this. I'm just kind of going through these settings to show you that you can indeed change these. The important one, there's an important one here on the U-axis. So all of this is the same, except now this is a linear axis, and we're actually talking about this slide here going back and forth on the head that attaches to the spindle, right? So I'm saying after load and before unload, And when I retract, I want to return to 0 position, which is going to be right in the middle. And a reason that you might want to do this is because when you change tools, this head might be hanging off the side, and that might affect the machine's ability to change the tool. So it's important that you always return to a safe position, which is typically 0, before and after unload on the actual U-axis, not the C-axis. Okay? Moving on, these are actually the things that were taken from the manufacturer's website. So this U-axis head, this portion, taken from the manufacturer's website, imported into GibbsCAM, and then you can see I have a number of different things imported into here. So I can swap them out. This is kind of how you build your tooling. So I know that this particular U-axis piece might have compatibility with any number of heads here. So you can add them all in here and then just kind of swap them out there and kind of build your own. You see I accidentally added one I did not want to add, right? But that's that, right? And these are basically saying that, hey, if I'm doing OD or ID work, hold on here, let me fix that. If I'm doing OD or ID work, which direction do I want to be facing? So that's essentially, kind of the same as this, right? I want to be facing outward versus inward. Well, you have to actually define that in here. So these attachment points, even though they're using the same piece, they're flipped so that we can have both of these positions here. Okay? And you want to, if I'm going to be using the same thing twice, but once in each position, be sure to define the tool twice. Okay? You can't just go back and switch it and then regen your operation, expect it to not mess other things up, right? But besides all of that, that's pretty much it with the intermediate tooling. Like I said, once you get it all set up and your database is populated and all that kind of stuff, it's pretty easy to actually run here. So I'm going to go through my ops, just kind of show you, but all of these operations are exactly the same as turning. Okay, so I'm just I extracted this profile and just select where I want to be machining. Did my markers just like usual. Because I'm selecting geometry, you have to click which one of these circles you're doing. But again, if you're familiar with turning, it's literally the exact same thing. And I'll even open up this process here. This is our OD contour, where we kind of make that chamfer and then take off some of the stock here. Okay, so again, just OD. We're actually already in a ZX plane. So typical turning stuff. Have a corner break. I have a line in. Everything else is pretty much exactly the same. There's really no considerations that you have to do. Now we want to make sure that you're selecting your correct coordinate system, right? So in this case, we're doing ZX top, which is the plane that I'm in right now. Okay, but other than that, that is the only thing that you really have to do. You should never have to change the holder angle or anything like that, because that's pretty static. I haven't seen any U-axis heads that can dynamically kind of move around at an angle like a B-axis head. But so that's a contour. We just did another contour here on the top. This is our undercut here with our grooving tool. We did a roughing operation here on the ID. And then a contour to clean it up. Kind of preparing all for our threading operation. And like turning, with some tools you also don't like this UN here, you also don't click the geometry. So again, it's completely identical to turning once you have all that intermediate tooling set up. Okay, so that's my little presentation on U-axis turning, and I hope you learned.